Hello and welcome to this short video developed for UBCO's ENGR 325 Civil Engineering Materials class project. This project is on Cross Laminated Timbers, and the group members are Christina, Devon, Eduardo, and Shawn. For this video, some of the learning objectives include looking briefly into the history of CLT, as well as design methods, manufacturing, environmental benefits, fire performance, and seismic performance. CLT panels are an engineered wood composite, still very much in its infancy of wide use adoption. An innovative wood product that was first developed in Germany and Austria in the 1990s. Since it is still developing, it continues to gain steady growth for residential and non-residential applications around the world, and recently it has seen an exponential growth in the North American and Canadian markets as it has many benefits that are now being realized. CLT panels have an extremely high strength-to-weight ratio, making them a great substitute for concrete. They are a secure, airtight, insulating, fire-resistant, and aesthetically pleasing material to utilize in floors, walls, and roof construction applications. They can easily be pre-manufactured in environmentally controlled facilities and quickly assembled on site, a remarkable feature which significantly impacts and reduces installation times. CLT design methods have been evolving considerably in the past several years due to the high adoption rate of this new technology. One such method was developed at UBCO Civil using the finite element analysis FEA on CLT panels to create a way to reliably calculate the in-plane stiffness of CLT walls with openings more accurately. All CLT manufacturers roughly follow the same general fabrication steps: detailed design, lumber selection, lumber planing and trimming, application of adhesive, panel layup, pressing, surfacing, cut to size, and finishing. CLT panels are manufactured using readily available standard dimensional lumber, meeting Canada's softwood lumber specifications. Manufacturers select material that is free of excessive twisting, cracking, missing corners, and any other indications of decay. The major and minor principal stresses in panels are also considered when selecting lumber grades. The major direction will require a higher quality of lumber, grade number 1 or 2, and the minor direction can be substituted with lower grades. As with any typical lumber manufacturing process, the timbers are required to be planed and trimmed prior to manufacturing, and this is because the timbers that arrive from the sawmills are never exactly at their specified dimensions due to imperfect cutting or any other damages caused during transportation. Adhesive application is normally carried out contact-free and autonomously on a production line. This happens just prior to layup, where boards are manually laid side by side to form solid wood layers. Each preceding layer is laid perpendicular to the preceding layer. Like plywood manufacturing, it is this alternating perpendicular placement that gives the panels their superior strength. Orienting the individual lumber pieces such that the bark and pith faces are alternating is crucial to mitigating the tendency of the wood to warp and bend as it dries, keeping the panels straight and plumb for years to come. Now that each layer of lumber has been sprayed with adhesive and laid up, they are placed in the assembly press. The entire sandwich of layers is then pressed vertically and horizontally in a large hydraulic press to ensure proper bond development is achieved between all the individual pieces. After pressing, the panel is dried and moved to a large industrial sanding machine, which will fine-tune the final thickness of the product to the exact dimensions required for the project. Tolerances on these large industrial sanders are often as accurate to 0.1 millimeter. The CLT panels are then sent to a machining station for fine cutting and jointing. This work is most often performed by a multi-axis CNC machine. It performs pre-programmed sequences using the shop drawings to accurately cut the openings for windows, doors, splices, joints, connection points, mechanical and electrical rough-ins, or any other required openings. Prior to getting shipped to the site, the CLT panels have to pass a final inspection by the manufacturer's quality control personnel to ensure that they meet the client's requirements. The panels are often enclosed in shrink wrap to protect them from the weather and external damage during transport, storage, and placement at the job site. A very significant advantage to using CLT panels is the ability to prefabricate entire core structures. The highest costs for any construction project is often the on-site labor, and the ability to prefabricate saves time and money for the contractors involved. When CLT construction was compared to traditional building materials, such as concrete, steel, and masonry, for mid-rise residential buildings, the cost was 15% less. And when this was applied to non-residential and low-rise buildings, the cost savings of converting to a CLT structure could be as high as a staggering 50% reduction in cost. Since the panels are manufactured in a factory climate-controlled environment, consistency is improved, and this creates less quality-related reworks on site. CLT panels are often sequenced to arrive on site as a kit, in order and as required, saving precious site storage space in dense urban environments. The construction benefits of CLT lead to more cost-effective construction, aesthetically pleasing structures, and a reduced environmental impact. Construction of the Brock Commons at UBC Vancouver campus last year demonstrated that its innovative mass timber hybrid structural system is economically viable, repeatable, and adaptable to other building types and uses. Using a crew of only 9, the mass timber construction was completed less than 70 days after the prefabricated components arrived on site, approximately 2 months faster than a typical project of its size. Construction materials research has been aimed at improving the properties of high-strength materials such as steel and concrete for economical large-scale construction. In the last few decades, however, the energy required in construction and operation of buildings has been identified as a major contributor of climate change. This discovery has fueled a need for eco-friendly building materials. With most governments being forced to address the issues of climate change, the construction industry is seeking new methods to conform to new codes and regulations. Statistics indicate that the construction sector may be directly responsible for up to 40% of the world's greenhouse gas emissions. New building systems using green materials such as CLT are being researched and developed to meet our needs without negatively impacting the atmosphere. CLT products offer a significant advantage in the fact that weaker species of fast-growing wood can be used to construct panels that also perform well structurally. Due to the fast-growing nature of these particular species of trees, the rate at which trees mature is greater than the rate at which they are harvested. This advantage is crucial for wood products such as CLT to be classified as renewable resources. The use of wood products in construction helps clear some greenhouse gases by trapping carbon from the atmosphere through photosynthesis. The carbon trapped in the trees is only released back into the atmosphere once they die, completing the carbon cycle. When dealing with projects that are designed to last 50+ years, this represents a significant reduction in greenhouse emissions. Due to their modular nature, CLT products can be recovered during demolition of a building and then reused in future projects. CLT products that are not suitable for reuse post-demolition can be combusted to recover their energy. Emission from these incinerators are treated so the process has no negative effect on the environment. To take full advantage of the carbon mass storage capability of wood, it is necessary to use more wood products in place of other building materials. CLT has a relatively high performance in fire. When CLT burns, the surface loses the strength and forms a black layer which can slow down the burning process inside. As CLT can have different combinations of layers, and some of them have protective coverings, the charring rates between each layer is different. There are 2 principal methods of analyzing the progress of wood burning. The reduced properties method is rare in practice because it only works for elements with 3 or 4 sides. The reduced cross-section method is based on the assumption that the charring rate of wood is notional when exposed to a standard fire and that the char does not improve the specimen's strength. This includes an additional 7mm layer of wood under the char that is negated and considered in having no effect on the strength of the wood. Earthquakes pose a huge threat to buildings, especially high-rises or less reinforced townhomes. British Columbia and the Pacific Coast is the most earthquake-prone region in all of Canada, and therefore, having the proper seismic performance and resistance to earthquake loads and stresses is vital for the buildings to have. Globally, full-scale tests of whole buildings, of CLT light frame wood buildings, has only been done 10 to 20 times, but many of these tests have proven that CLT buildings do withstand the lateral and cyclic stresses and loads of earthquakes. As evidenced in this video provided by Simpson Strongtie, whom was present and participated in this test, the world's largest full-scale shake table test shows the intensity and ferocity of an earthquake, and how a CLT wood structure withstood these intense forces. These shake table tests, in addition to the careful scrutinization of CLT panels, how they are made, their composition, their strengths, and bending, all of these factors and studies have led towards a growing unanimous agreement that CLT panels can withstand earthquakes and may be used, hence why we are seeing more and more of these CLT-based structures. We find CLT to be a very good construction material, a material which can be made in bulk and whose raw materials are easy to gain access to, all the while being sustainable. Something which is light yet strong, easy to transport, easy to put together, which can also be prefabricated and delivered in modules, taking less manpower to assemble at a much faster rate than other building materials and components, and shown to be resistant to fires and has a very solid resistance to earthquakes. CLT has proven itself time after time, and that it will see more and greater uses in the many years to come, perhaps even becoming a main staple in most places around the world. This concludes our video on Cross Laminated Timber for ENGR 325 at UBCO Okanagan. We would like to thank you for watching and for your time.